use the chain rule for partial derivatives to find partial of w with respect to s, partial of w with respect to t, if w equals x squared minus y squared, x is equal to cosine of s plus 3t, y is equal to sine of s plus 3t. So first, I write down my equations. So the chain rule is going to be, what do? I'm going to have partial of w with respect to s. When I write this fraction, I'm going to give myself space. And the idea is going to be, we're just going to stick the intermediate values in to these spaces. That's how I remember my rule. So what's in between? That's going to be x and y. So we'll put in partial w with respect to x times partial x with respect to s, partial w with respect to y, partial y with respect to s, and then we repeat the whole thing for partial w with respect to t. Let's grind out each term in our equations. First, partial w with respect to x. Here, since I'm doing a partial, we're going to treat x as the variable, y is going to be a constant. So we get 2x. My final answer is going to be in terms of s and t, so I'll substitute in for x cosine s plus 3t. Same idea applies to partial w with respect to y. I get minus 2 sine s plus 3t. All right, for the remaining partials, so it's going to be partial of x with respect to s or t, partial of y with respect to s or t, same idea. Here, we're dealing with s and t instead of x and y. So for instance, if I do partial of x with respect to s, okay, x is cosine s plus 3t. I want the derivative with respect to s, so we'll use the chain rule. Derivative of cosine is minus sine. Inside is s plus 3t. S is our variable. T is treated as a constant. Derivative of s plus 3t is going to be 1. So we get minus sine s plus 3t. Similar procedure applies to the other three. What's left? Just to reassemble all of these terms in the equations. So we put these together. Now, one thing you can note, which will be good for checking our final answer, 2 times sine of an angle times cosine of an angle is equal to sine of twice your angle. So that's our double angle formula for sine. So I can simplify our answers. For the first one, we get minus 2 sine twice our angle. So I'll have 2s plus 6t. Partial w with respect to t, same exact idea. We're going to wind up with a minus 6 sine 2s plus 6t. How does this help us with a check? Well, if I take our w, treat it as a composition, meaning get everything down to s and t. Okay, we take our original function. I wind up with cosine squared of an angle minus sine squared of an angle. So that's going to be just cosine of twice the angle. So our original function is really cosine 2s plus 6t. And now I can just do a straightforward partial with respect to s or partial with respect to t. For instance, if I did partial with respect to s, okay, well, it's just chain rule. I'll have minus sine. We put the inside back in. Then I take the derivative of the inside with respect to s. That's going to give me a 2. So derivative with respect to s is going to be minus 2 sine 2s plus 6t. And you notice that's the answer we got from doing it the long way. Same idea is going to apply when I go for the partial with respect to t. So I'll just let you work that one out.